In this video, we're going to look at using trigonometry to find missing angles in right-angled triangles. So we're using trigonometry, so the first thing we're going to do is label our sides. 15 over here is our hypotenuse. The 9 is opposite the angle, so that's our opposite. And the other one is the adjacent. And then we're going to remember our phrase that we use for trig, which is SOHCAHTOA. Okay, SOHCAHTOA. And we're dealing with the hypotenuse and the opposite, so we're using SO with the O and the H in it. Remember what this tells us. The SO tells us that sine of theta, our unknown angle, is equal to the opposite over the hypotenuse. So in this case, sine of theta is equal to 9 over 15, which we can simplify down to 3 over 5. Now, to work this out, we have to use a button on our calculator, the inverse function. So theta is equal to sine inverse, that's sine to the power of -1 on your calculator. It's normally the shift key and sine. And then in the brackets, we put 3 over 5. And when you type that into the calculator, you get a value of theta as 36.87 degrees to 2 decimal places. Remembering that we're measuring an angle, so the units are degrees. Okay, we're going to have a look at another one quickly. Once again, we're going to label our triangles. So we've got the hypotenuse over here, the adjacent is the 12, and the 7 is the opposite. And as always with trig questions, SOHCAHTOA to help us work out which one we need to use. And we're using the adjacent and the opposite, so we're using TOA. And tan theta is equal to the opposite over the adjacent. So in this case, tan theta is equal to 7/12. We can't cancel that down, so we're going to leave it like that. And so theta is equal to tan inverse, tan to the power of -1, of 7/12. And when we type that into our calculator, we get a value for theta of 30.26 degrees to 2 decimal places. And that's how we use trigonometry to find missing angles in right-angled triangles.